Yuri, we get to talk about mountains right now. How great is this? Nice picture, Yuri. Mountains. So, what do those words mean? We'll have to come back to them in a second. But windward, leeward. So here's the main thing. If we draw the direction of the wind, the way that it comes, what's a good color for that? How about purple? If we draw the direction of the wind, the way that it comes, the diagram could be flip-flopped. Usually you see it this way. Based on the land and the direction that wind blows, you get some climate patterns. So in general, this is going to be the wet side, and then this over here is going to be the dry side. There's some reasons for that. When air hits a mountain, or anytime air gets forced up, it does this, RECCC. And then on the back side of the mountain, SCWEC. Okay, that's the way that the Mr. Spado and Yuri method of remembering it. RECCC, SCWEC. It's called the windward. That's the side the wind hits first, and then the leeward is the back side. Okay, so what are these words? Rising, expanding, cooling, condensation, clouds. That's in a specific order there. When the air hits land that makes it get forced up, it rises. When air rises, it expands. I'll show you a little animation to show that. When you make air expand, it gets cooled off. Whenever you have air cool, it makes condensation, and then that condensation makes clouds, which is going to make rain. So this is a very wet side of the mountain, and it's a cooler side of the mountain because the air is rising up. On the back side, the leeward side of a mountain, each of these are the opposites of these. So I'll give you a second. See if you can figure out what's the opposite of rising? Sinking. What's the opposite of expanding? Contracting. What's the opposite of cooling and condensation and clouds? Warming, evaporation, and clear. So all the things that happen here, the opposite things happen on the backside of land. That's like a mountain. And so here you're going to get warmer air and drier air. Here you would get places that are like rainforest or really, really wet climates. And here you would get desert-like climates. So that forces large-scale climate patterns because rising, expanding, cooling, condensation, clouds. This is all going to be wet, and this is all going to be dry. Okay, so if we add some gas to this container, this simulates a parcel of air, and we add some gas molecules, okay, and you can see as they bounce around, they bump into each other. The faster they move, the more heat there is. So if we add a little heat here, look up here at the temperature, you can see if you add heat, it's going to get warmer, and you can see those molecules kind of bouncing around faster, okay? Now, if you expand the gas, if you give it more room to bump out, all of those bouncing off of each other molecules are going to spread out, and you can see what happens to the temperature there. As they spread out further and further and have a chance to expand, the temperature drops. That's what happens as you go up in the atmosphere. There's less pressure, there's less air molecules above it, so it has a chance to expand, and then it cools as you go up. Now, if you contract that gas into a smaller container, that simulates like when the air sinks back towards the earth and there's more pressure, and you squeeze those molecules back together. Even without adding heat, just by squeezing those molecules together, you can see that temperature goes back up, okay? So when the gases was expanded, it cooled off, and when it contracts, it heats up. Yuri thought it would be good to draw one more quick picture just to explain that animation real quick. So if you start out with a parcel of air, if it goes up in the sky, there's less air pressure up here, so it expands, and you can see it's just the molecules are further apart, so this makes it cooler. And if you sink a parcel of air closer to the surface of the earth, there's more pressure, so those molecules are squeezed together, so it gets hotter. So it's all about where's the wind coming from. You could flip this diagram completely and have a mountain, okay? And the wind would be coming from this way, and everything would be reversed. So it all starts with here. And please remember, you've got your RECCC, SCWEC. So compared to the temperature and water vapor content at X, the temperature and water vapor content at Y are, they did that little head fake, which I've mentioned a few times. They start with one thing and then they switch to another direction. What's it like here? This is the warmer and drier side of the mountain. So that's where you have your sinking, contracting, warming, evaporation, and clear side of the mountain, the leeward side. Usually the diagrams are drawn from the same direction, but they will flip every once in a while. I keep saying that. Clouds are forming on the windward side. RECC, rising, expanding, cooling, condensation clouds. Here. Cloud formation at 2 is the direct result of rising, expanding, cooling, condensation clouds. It's really a similar question most of the time. They can't ask it too many ways. Like I said, sometimes they'll flip the direction, but that's about all they could do. This is one way that they can ask a different way. So coming from New York, it's going down the higher elevations and it hits water, which it picks up some moisture, and then it goes into Vermont, which is going back up some elevations. So compared to A, this is the sinking side. B is the rising side. You're still going to have your RECC, but it'll be over here. And then your SCWEC would be over there. So B is still going to be cooler and wetter. That's a different way to ask the same kind of concept. So hopefully that makes sense. All right, so the same concept, we've looked at lake effect snow during the year, and we'll have a separate video on that. But as the wind comes across the lake, Lake Ontario, and it picks up moisture, what happens is it comes out of the lowlands and it starts to hit the plateaus and the mountains, and it rises up. So you get a lot of rising, expanding, cooling, condensation, and clouds on this side of the Adirondacks and the Tug Hill Plateau. So that's why they have really high snowfall amounts and higher rainfall amounts than the rest of the state, because you get that, it's called orographic lifting. So anytime air rises up, plateaus and mountains, you get, rain, snow.